As we think about even and odd trigonometric functions, let's go back to some power functions that we may be a lot more comfortable with. So in this case, let's think about f of x equals x squared. So in this case, we're going to be inputting an x value and outputting a y value. So as you can see from our x squared graph, if we input a positive 2 into our function here, we're going to get a positive 4 coming out. Whereas if we input a negative 2 squared, that means 2 copies of negative 2, we're also going to output a positive 4. So in this case, we refer to this as being an even function because our inputs, whether you input a positive or a negative x value, you get the exact same y value coming out. So this is kind of our test that we've used in the past, maybe in algebra. As you plug in a negative x, it turns out being the exact same as when you plug in a positive x. So one thing that can help out on these is if you think about them as ordered pairs, if you know the point xy is going to be on our graph, you also are given this other point, negative x, comma, positive y as well. All right, so that's how we define an even function. We say they have symmetry with respect to the y-axis. So if we had put a mirror right here on the y-axis, what's on the right-hand side and what's on the left-hand side is going to be a mirror image of one another. Next, let's think about our x cubed graph. Okay, kind of similar here, but a little bit different. We plug in a positive x value, such as 1, we're going to get out a positive y value as well. So like the 0.11 is on here. It's odd because if you plug in a negative 1, you're going to get out a negative of this exact same y value. So the ordered pair negative x, negative y is going to be on here, meaning that the same y value is here, but it has the opposite sign as the original point. So if you plug in a negative x as your input, you get out negative of f of positive x, which is a little bit confusing, but these are said to have symmetry with respect to the origin, meaning that kind of if you mirror this twice, if I took this 0.11, I mirrored it across the y-axis, and then again, I mirrored this across the x-axis, I get to this point down here. So that's referred to as symmetry with respect to the origin. Now let's see how this connects together with our trigonometric functions. So with our trigonometric functions, we are thinking about rotating using angles. So we're going to be inputting an angle t, and either it'll be a positive angle and we'll rotate in the positive direction, or it'll be a negative angle and we'll rotate in the negative direction. So you want to be a little bit careful with this. Remember, we're inputting some angle t. We're going to be outputting an ordered pair, so an x value and a y value as we go through this. It's a good thing to remember that our cosine is going to represent the x value for each one of these ordered pairs, while sine represents the y value. So as we're thinking about plugging in here, if we rotate in the positive direction, we get positive x. If we rotate in the negative direction with our angle, we still get positive x. And since cosine is representing the x, notice that if we plug in a positive value of t, the angle is being positive, that'll just give us an x. Whereas if we input that negative t, we still get an x out. So these turn out being equal to one another. These identities, the even odd identities, we typically use whenever we have a negative inside of any one of these trig functions. We want to get that out of the trig function. We can eliminate it as long as we know these identities, that if we had a cosine of a negative t, we could replace that with simply cosine of positive t. And that goes hand in hand with secant, as these are reciprocals of one another. However, the other 4, we can say, as we plug in a negative value, a negative angle in here, we want to eliminate that negative from the inside. We would need to include a negative in front. And you may be saying, okay, I can sort of see it like with our x's and y's with these ordered pairs, that the y value, if you plug in a positive t, it's going to turn out being positive y. Whereas you plug in a negative angle, a negative value for t, you get out a negative y, which represents our sine. Okay, so you may be saying, well, where does tangent of negative t come from? Like, how do I reason through that? Well, what we can say is that tangent of negative t can be defined to be sine over cosine. So we can say sine of negative t over cosine of negative t. All right, and after you redefine that using the quotient identity, what we can do next is you can kind of use the sine and the cosine, what's listed up here, that we can replace sine of negative t with negative sine of t. And we can replace cosine of negative t with simply cosine of t. All right, after we've replaced those two, we have this negative out in front. So you can visualize this as a -1 multiplied by sine over cosine. And sine over cosine is defined to be tangent based on our quotient identity again. All right, so that's kind of where they each come from. Let's use these in a couple quick examples. So if we know that secant of some angle t is equal to 2, so we can say secant of t equals 2, then we want to know what is secant of negative t going to be. So our goal here is figure out secant of negative t. Well, using an even odd identity, what we can do is go up here and say secant of negative t is simply equal to secant of t. And then we can replace secant of t with what we were given. Okay, so that's going to equal 2. All right, one more quick example here. We want to know if the cotangent of an angle t is equal to the square root of 3. So what's given to us is cotangent of t equals square root of 3. We want to figure out what's the cotangent of negative t. All right, so again, our even odd identities, what we can do is go up here to cotangent of negative t and replace that with negative cotangent of t. So rewrite it so it has a positive angle on the inside here. So cotangent of positive t. All right. Lastly, what we want to do here is we are given cotangent of t, so we can replace that in the square root of 3 in where the cotangent of t is here. We're going to get negative square root of 3 as our solution. All right, hope this helps out. Even odd identities, use these whenever you want to get rid of a negative from inside of a trigonometric function. Hope this helps. Good luck.